So here we have a kind of fucked up drawing of a cow, and it is, let's see what it's recognizing it as. See, it's because it's a screwed up cow, it doesn't recognize it as a cow, it recognizes it as a combination of things. And that is what I mean by when somebody does something, you turn it into a visual, and you compare it to like the actual results, and how close it is. You know, how accurate or how well they did, and how much of these other factors comes into play is an indication of where there might be problem areas. Let's try another one. Let's try this. So this is a drawn duck. And obviously what I'm talking about is converting the data into a kind of graphical format. You know, the test results into a graphical format, and then running this kind of comparison versus what the, you know, correct answer is, or the correct way of doing it is. So this one actually came out pretty good. It does look like a duck. So obviously there's going to be some trial and error here. Okay, so now I can take other pictures. I'm just gonna throw some random objects up. Oh, how's this? Here. And so in terms of like actual evaluate assessment, so that came out as a cow. That picture was a cow, but there was nothing else to compare it to. So let's see what the output is on that. And yeah, I guess you could, you know, it kind of looks like a cow from that point. So let's see what I look like. All right. So the picture is what is turned in. Whether or not it is correct or not is how it compares to the actual, you know, answer, which would be these reference points here, and however much is bled into the other references shows you possible areas of where things are going wrong. Obviously, there's like an algorithm that's needed to do something like this, but if you read the white paper, it kind of gives you an idea of how that works. So my picture looks like a duck, a sailboat, and a cow. Let's see. Well, it's, you know, I don't know. Somehow I got duck, sailboat, and cow out of that. Okay, so one more picture, which would be a cassette tape. You see, by the amount of deviation from the actual answer, you can get an idea of where problems areas would be. And again, this is algorithm. It's, you know, it's basically converting the data into visuals, and so this cassette tape has no idea what it is. So this is like an anomaly. This is like somebody suddenly does something that totally triggers off the system that something's wrong. right? Because it's got all these three things. It doesn't recognize it as anything. So somebody did something totally wrong in that situation. And another thing you can do is you can change like the darkness of this. So let's see what happens when we darken this. And so these changes, like darkening it or blurring it or rotating it, would correspond to, different approaches of doing like a math problem, say. And okay, for some reason this comes out more like a duck. Um, I mean, all right, I guess you could kind of see like a duck right there, So, so by darkening it, it comes out more right. So maybe like the actual answer was to darken it. And that also corresponds to different ways of how a person solves a problem. Obviously, this has to be mapped out. There's going to be some trial and error, but this is the general idea. All right, I'm going to stop this and hopefully you get that picture.